everyone. We want to define the concept of flux today. Now imagine that you have a river or a stream that is flowing and you want to put a barrier, let's say a porous surface there, and you want to talk about how much of the liquid is passing through the surface at any moment. So if this is my surface, z equals f of x, y, and n is the unit normal to the surface, then the fluid can be passing in any particular direction. So if I want to map the amount of surface, the fluid that's flowing through the surface at any particular place, I would find f dot n, that would be this amount here. If I did it over ds, then this would represent the amount of fluid passing through per unit of time. If I wanted to add up all of these, I would have the double integral over the surface of f dot n ds, and this is what we define to be flux. Now, we already know the surface area parameter ds is fx squared plus fy squared plus 1 dA. What we need to now consider is the f and the n. Now the unit vector n we know is in the same direction as the gradient to the surface. But because our surface is defined as a function of two variables, I need to create a three-dimensional surface. So we will define a new function, g of x, y, z, to simply be the difference of these two, z minus f of x, y. Because our outwards normal is pointing upwards, we want the partial derivative here to be a 1. If my normal was pointing downwards, we'd simply subtract in the opposite order. Now we know that the gradient of g, in this case, is going to be negative fx, negative fy, comma 1. Therefore, the length of the gradient vector looks very familiar. This is also coming from the surface area parameter. So therefore, our gradient vector, our normal vector, is 1 over the length of the gradient vector times the gradient vector itself. So now when it's time to evaluate this integral here, what we do is we first find f dot n, but we leave n in the form of, like this, 1 over the length of the gradient vector times the gradient vector. We don't multiply this through, because then in the next step, when we do f dot n ds, the surface area parameter here, if I did it right, should cancel with this portion here, leaving a fairly simple integration. Now the next thing is, my force vector probably has a z in it, but because I'm doing a double integral over a surface, I can't have three variables. So what we do is we replace z with f of x, y when we get to this part of the problem. So now we have something with only two variables in it, and I'm integrating over the region in the xy plane at this point. Now you want to look on Canvas because I've posted some lecture notes on how to actually calculate the flux of different surfaces.